How do you repair a geothermal heat pump? Today, I'm going to walk you through the repair of this geothermal heat pump. We're going to figure out what's wrong together, and then I'm going to give you some most common problems that I find in the field working on geothermal equipment. You're watching HVAC Tips for Technicians. This is Taddy Digest. I'm Tad. Let's get started. Let's take a look at the geo setup, the flow center, and then we're going to get into the repair and figure out what's wrong. So here is the geo unit. We've got our return coming in on the left side. We got our supply going straight up. Looks like they are making use of the de-superheater. So they've got a water tank here, and you can see the cold water inlet line is going in, and then we've got this line going out, right? Make sure you don't have a check valve in the way, because you never want a check valve on your de-superheater line, because your circulator pump's going to go bad, right? Because it's going to not pull water. It's going to be dry. So that's one tip. We got our flow center right here, and we've got two pumps. That's nice. So we've got a loop in the ground. We're not using a well for this one. It is a loop. Now we've got our inlet and our outlet with our PT port so that we can measure our pressure. I've already hooked my gauges up. Standing pressure is around 200, so we know we got plenty of refrigerant. We've got our ECM motor right here, and I'm pretty sure that we have a constant 240 volt, and then we get, with this 16-pin harness, looks like, we get a DC signal out from our CFM board. See the CFM board? And then you should have a CFM light that blinks, and that's an indication of how much CFM. Okay, so we got our contactor, supplies power to the compressor, and then I'm pretty sure also the pumps. Yes, we got our capacitor down there. I've already got my gauges connected, and I'll show you a low side hose goes into the middle line of the reversing valve, right? That's our true suction line. And then our high side hose is connected to the discharge line. And there's our circulator pump for our de-superheater. So that's nice. So here's our coaxial, right? There's our coaxial. Now, customer says it's not working in the heat mode. I've already put the thermostat into the heating function, and we're energizing the heat mode. I took off the wire for the coil of the contactor so that it wouldn't come on and I could talk to you for a minute. Let's go ahead and energize. All right, never leave this panel off when you are operating in the cooling or heating mode. It looks like we have a problem. Our motor is not spinning. So we need to check the call to that motor. Are our pumps running? We got the burp screws out, and this pump is not running, but this pump is running. So we found two problems so far. This pump is not running. Which, is it on? Let's go to medium. It's variable speed pumps. Yeah, it's not doing anything. So let's make sure we have power to this pump, and let's check our water pressure, and then let's check the call to the motor, because our motor should be operating right now. All right, so get your meter, put it on volts AC. Let's come over here where our thermostat inputs are, and let's go between C and G. We should have a call to our fan, right? C and G, we got a call to our fan, and then it looks like there's another spot we can check. Here, I'm just gonna put my meter right there. Take a look at this. So we're gonna go to ground or common here, same thing. One side to common and one side up here. Look at this board. It says G. So C to G, what's the meter say? 26. So we got voltage. There's no reason why our fan should not be working. Now, here's a 16-pin harness, and we should have DC voltage coming from this plug to our motor. Let's go up here to the motor, because even though the contactor is no longer energized and closed, and our compressor is no longer getting the voltage it needs to operate, our fan should still be running, right? And what's happening is we're tripping out on high head pressure. Why? Because during the heating mode, this coil right here becomes hot. This coil is the condenser during the heating mode. That means that this coaxial is the evaporator, okay? What does the evaporator do? It absorbs heat. Where is it absorbing heat from? The water, all right? So we're rejecting heat into the house. Let's go ahead and put our meter right here. Volts AC. And let's turn the light on. Should be able to see better. Let's take our plugs off of our motor. 16 pin. And here's our, ooh, looks like we got a little burn mark right there. Okay. Checking the white and black wire. 246 volts. All right, so this is where I had my leads, white and black. All right, we got a constant 240. Then we're gonna go to our plug here and we're gonna make sure we turn our dial to volts DC. All right, now we're gonna go, let's see. I'm gonna go to the 2 wires on the end. What do we got? 5 volts DC. All right, so we've got a call to the motor and we've also got power to the motor, but the motor's not working. So obviously the motor's bad. So we have an indoor motor that has to be replaced. Hopefully we'll get it under warranty since this equipment is only 9 years old, so that's great. Motor under warranty. Now let's proceed forward and let's check power going to the pumps, all right? So where does the power come from? So we have our there's a green, a white, and a black wire. All right, the white wire for the pumps is right here. And it goes through a set of normally open contacts, right? This is pump number 1, pump number 2. Whenever this relay closes, whenever it gets 24 volts, then the relay closes, that provides one side of the line to the motor. The other side of the line comes straight from the contactor. See that? So contactor has to close for those pumps to energize. I like that. Now, when do we get a call? We get a call whenever we have a call for cooling or heating. Because look, see that? That is one side of the coil of that relay. See, Y. So that's Y. The other side is C. So we're gonna check power here, and then we'll be able to know if we have power to those pumps. So we have to give it a call first. Right now, we're not gonna give it a call because it's blinking one. I think it's just one time. Yeah, one time, which means HPC. So what is HPC? That is high pressure cutout. I'm almost certain. Checking the schematic, here's our blink codes, and 1 means high pressure fault. Reset power, so we should get a call here in a minute, and then we'll be able to check power to the pumps. In the meantime, I'm gonna go ahead and use my loop gooser tool and stick it in the PT port, and it looks like I have no pressure. None. All right, let's go into the other port, see what we get. Nothing. That is very concerning. I'm gonna go ahead and just leave this right here so that we can see what that pressure is while the pumps are running, but looks like we may definitely need to add some water and maybe even add a pressure reducing valve onto the flow center from our water supply line. If you don't know how to do that, I've got a video on how to do that. I'll put the link for that video down in the description. All right, so we've got a call for heating. Right now, I've got one wire off the coil of the contactor so that it doesn't energize, so that we can check the coil of this relay that energizes one side of the line for that pump. And what do we got on our meter? 25. So that means that this relay should be closed. Is it closed? If we measure voltage and it says 0, then that means it's closed. All right, let's check the other one. If we're reading voltage, then it's open, all right? If you don't know anything about relays, I'll put a video down below so you can learn more. So now if I measure from here to this side of the line, right? Or from here to this side of the line, we should have voltage, right? All right, so let's go ahead and do it. Here we go. So here we go, this side, 240, this side, 240. We have voltage to our pump. Let's go check at the pump. Checking at the pump, 240 volts. Now let's go look at the pressure. Look at how high the head pressure is. Probably cuts off at 600, watch this. 592, 596, 600, oop. Just kicked out on high pressure again, but we did check voltage at the pump. Let me show you where I checked that power. So right here, it says N and L. There's a little capacitor in there. Got to take the cover off. Phillips screwdriver. There's one Phillips screw. You can take off the cover. Very easy to replace these pumps. It looks like the pump has failed. Very easy. Don't have to replace the whole flow center. And I think this is all plastic. Some of the metal flow centers, they actually rust out in the back. So hopefully this plastic one, you won't have those issues. But easy to replace. You've got 1, 2, 3, 4 Allen screws. You remove the pump and it comes with the little impeller, and then you place the new pump in place, and then 4 screws to tighten it back to the flow center, and you're done. If you don't know anything about replacing pumps, I've got a video on that. I'm going to put a bunch of videos down in the description so you can learn more about geothermal. So now we know we have an indoor motor that's bad, needs to be replaced. It is under warranty. I got the motor headed this way. It's actually 17 days out. So customer will have to wait 17 days, but they're cool because they got it under warranty. And I don't blame them because this motor is probably $1,000 plus. Now we've got a pump that's failed. We're gonna get that pump replaced. Right now, we're gonna go ahead and pump this thing up with water. So take a look, loop gooser tool. If I open it up, this is how the water will go in. Right? We've got a water hose connected. Now we're going to go ahead and put this into the water inlet line. And be careful, you want to make sure you screw it in, and do not put weight on this, because if you do, you'll break the needle. All right, now watch the gauge. We're going to open it, watch. See, water's going in, but we need help with that water going in. So we're going to go ahead and energize the contactor and start the pumps. See? Now we need to put those burp screws back in probably, because we're probably going to have more water. But I'm hoping that we can get that pump, if it's seized up, maybe to unseize, and maybe both pumps will start working. We're going to keep the water on it and see what pressure we can achieve. All right, take a look at our water pressure. We really need our pumps running. That way we can actually put a good amount of pressure. And look, we don't even have 5 PSI. This is the inlet pipe, and this is the outlet. Same thing. We got more than 0, but this is not enough. We need to have that pump repaired, and then we need to use a flush cart. Why do we not have water in the loop? The loop could be busted. There could be something leaking in here, maybe the coaxial. I didn't see water, but there could be something leaking, especially when we do get water in here, we might be able to see it. So loop, coaxial, it could be that whoever installed it didn't use a flush cart, and if you don't use a flush cart long enough, and you don't use a flush cart at all, then you don't get all the air out. And then after the first summer and winter makes the pipes contract, and then summer makes the pipes expand. After that happens, then you've got air in the system, your water pressure is lower than what it was. So if you want to learn more about how to fill up a geothermal unit, go check out those videos I put in the description. You want to learn how to replace pumps, go check out those links. As far as replacing pumps, it is pretty simple. You're going to take off these covers. This is how you can isolate the loop from the geo. So you would basically take this valve and you would turn it, and then you would take the other valve, turn it, and then you would take your pump off and then turn it back, or yeah, put your new pump in, then turn it back, and then hook up the loop gooser or hook up your flush cart. And these are removed, I'm pretty sure, for flushing. So you would take this off like this. This is where you'd hook up your flush cart, I'm almost certain. Most common problems, let's go over it real quick, and then we're gonna get out of here. Common problems I find in the field with geo units. You've already seen a few, right? I've had bad ECM motors. I've had leaking indoor coils. I've actually got a video replacing one of these coils. A very rare problem, but I have run into it, is a bad reversing valve. I've had to replace a reversing valve on a geo. I've had to replace a coaxial on a boat geothermal unit. That was terrible because the height inside the boat where the geo was like this. So you're crawling. It was not fun. I've had leaks. I've had leaks in the refrigerant lines where two pieces of copper were touching. I've had, the most common problem is no water. No water because improper installation or follow-up. They didn't come back, use the flush cart. Oh yeah, filter's dirty. Bad flow center's leaking in the back because it's metal, it's rusted out after 10 years. Pumps are bad. Pump went bad because there was no water. The loop was bad. In water furnaces, there is a sensor in the pan, and that sensor it rusted out. And it was saying that there's water in the pan, but there wasn't. But pan being stopped up, that could be a problem. De-superheaters, I've had those, I think, leak, and I've got a video on how to replace a de-superheater. I think that's it. You know, you got to replace your filters. Hope you enjoyed today's video. Hope you learned something. If you did learn something, let me know what it was down in the comments. If you got a question, remember, questions can lead to new content, so put your questions down in the comment section. If you don't have a question, that's okay. Let me know who you are. Let me know where you're from. If you liked the video, hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.